Waiting for a few more people to rejoin. Ten more seconds. Okay, so just really quickly in the last 5 minutes, I want to go over some of the questions in this. So just a few things I probably should have said that I didn't. First of all, hydrogen atom is 1 proton and 1 electron. It's the simplest element, so that's what's being represented here. 1 proton in the nucleus and 1 electron that can be at different energy levels. Now, what you should have noticed is that the electron only jumped if the light we shot at it had the exact same energy difference as the differences between these energy levels. So if we wanted the H alpha, oops. But we can also see that another one of those questions was, why does the electron always fall back down? And that's because hydrogen, everything in the universe always wants to be at the lowest energy state it can possibly be. So if there's nothing bumping into this hydrogen atom, if there's nothing heating it up, no light being streamed at it, that electron's going to go down to the lowest energy level it can be at, which is the ground level. And as it does that, it'll emit the same wavelengths as it absorbed to get bumped up. So what's really cool, why this is so important, is that each element has its own spectral fingerprint. So, oops, let me jump here. In questions 7 and 8, you kind of get at this. This is what we would expect to see if we had a big thing of hydrogen gas and we heated it up and we looked at its spectrum. We would expect to see a bright line in the red. This is that H alpha emission, so moving from energy level 2 to 3, or then falling back down 3 to 2. So when you use that H alpha light, it emitted at this 656 nanometers, or yeah. So if we move this guy to 656, I guess it's going to say 657, and now we shoot a photon. It's a red photon, and it bumps it up. And then it emits that photon again as it falls back down. So, so this light that gets emitted from hydrogen corresponds to an electron falling that specific energy, those specific energy distances. So these are all different transitions, different photons you could have fired that would have actually caused a hydrogen atom to emit light. The other thing that's really, really neat is that depending on how many protons you have and how many protons your element has, those energy differences between the energy levels are going to be different. So different elements absorb and emit different colors of light. This is for neon. So neon gas has a lot of energy level differences that are in red light, and a few in green and 1 in blue. So unlike hydrogen that just had those 3 big lines, neon we can see has a lot of energy levels that are in the observable part, the visible part of the electromagnetic spectrum. So one thing I'm going to ask you to do with your diffraction grading in that lab is to go try to find a neon light, a neon sign, and look at the spectra of that sign. You should be able to see these lines, which is really cool. And we can use that to try to figure out what stars are made of by looking for these specific lines that correspond to specific elements and using that to figure out what's actually there. Let me see if I could. Yeah, so this would be a spectrum of a star. I'll start here next class too, so don't worry about this. I'll go over this again. But here we see brightness, intensity of the light, versus wavelength or color. And we can look for specific lines that are either light being absorbed or emitted. And that'll tell us what is present in the surface of a star, what elements there are, what it's made out of, which is really cool. It's something we can use to look both at stars and at planets around those stars. So when we're trying to characterize planets around stars, we can look for this. It's also similar to that discovery on Venus. They found phosphine in the atmosphere. I think they were using spectra to do that. So all of those kind of discoveries, we're finding the composition of something by looking at the colors that are the wavelengths of light that are emitted, and using the fact that specific elements can only emit specific types of light, specific colors of light. So we can use that to figure out what's there. Okay, so that's all the time we have for today. I'll stick around if people want to ask a few questions. Make sure that you do submit that quiz so I can actually look and see how you're doing and give you some feedback. But otherwise, I will see you next week so we can wrap this up and start talking about the sun.
Thank you.
Thank you.
Thank you.
Thank you.